By the end of this Blender tutorial, you'll be able to make this mesmerizing Plexus effect using geometry nodes. And it's easier than you think. We'll take an incremental approach to solve one small problem at a time. Let's dive in. All right, the first thing, let's press A to select everything and press X to delete. Now let's Shift A to add a monkey. This is more complex geometry, so it will give us a better spread of points that we can work with. And let's jump into our geometry nodes tab. I have a slightly different setup here just to get a bit more real estate for the geometry node graph. We'll add a new geometry node there. And we do want to keep this geometry, the monkey, but we do want to convert this to a point cloud so that instead of this mesh, it'll be several points just floating in space. To do that, we'll Shift A and we'll add a mesh to volume node. And this turns that geometry, that mesh, into just a cloud, basically, into volume. But the next thing that we'll do is we'll distribute the points in the volume. So now we get a couple points, there's not a lot there, but we can change this density to be whatever we want. And that's good for now. I don't want to work with too many points just as we get started, just so that it's easier to visualize and conceptualize. So for the Plexus effect, what we need to be able to do is take a single point and draw connections from that point to every other point, like so. And then we would take another point and draw connections from that point to every other point. And so we can look at our point cloud here. We see that we have seven rows. There are 7 points on the screen here. So what we want to be able to do is start at point 0. Take this point, we'll say it's here, and connect to every other point. 1, 2, 5, 6. And then we'll go down to point 1, which might be here. And we'll connect to point 0, 2, 3, 4, 5, 6, and then point 2. So let's start simple. Instead of worrying about every point connecting to every point, let's just worry about one point connecting to every point. And we can do that with a repeat zone. A repeat zone is a loop. It will loop a certain number of times, and within the loop, it will perform whatever action is specified. And the action that we want is to connect the first dot with all the other dots. So to connect to all the dots, we need to perform this loop a certain number of times. And the number of times we need to do that is with the domain size. If we take this point cloud and change this to point cloud, and then we take this result and plug that into the iterations, now this loop will run as many times as there are points in the point cloud, in this case 7. So now that we know how many times this will loop, we can start to connect the first point to all the points. So let's take a sample index node. We'll take this geometry and we'll sample index 0. That means we'll read information from this row. It could be the radius, it could be the position. In this case, we want to know the position of this node. And the position is a vector. So we'll change this from a float to a vector. And then we'll Shift A to add a position input. So the output of this will be this vector value right here. So that will be the position of our first point. Now we can compare that position with all the other points by looping through the remaining points. So we can sample index, and we'll want to take this geometry, but the index needs to change for every iteration of this loop. So let's click this repeat zone node. Press N to pull up the sidebar and click the node tab here and press the plus button. And we'll change this to index. In fact, I know that we'll actually be nesting this later. So let's call it inner index. And let's change it to an integer. So now when we start this loop, the very first time, we'll start with an inner index of 0. And that value will come into the actual loop and flow through it to the end of the loop. And then it will come back to the start of the next step. In this case, it will just be passed through. It will be 0 at the end, it will be 0 at the start. But we want to increase that by 1. And that will be the index that we'll sample here. Again, we'll change this to a vector. Take this position so that we're reading the position of these other indices. And now we have our 2 positions. So what do we want to do with these positions? Well, for the Plexus effect, we want to check the distance between these 2 positions. And if the distance falls within some threshold, we'll actually make a a connection to those points. We can check the distance between these 2 points by taking a vector math set to distance, plugging the 2 in, and now we get the distance output here. So now we can compare that with the less than. So if the distance is less than, say, 0.5, this is just arbitrary for now. If the distance is less than this threshold, we will make the connection. Well, how do we make the connection? We can Shift A to bring in a curve line, and these 2 points, the start and the end points, will be, the start will be the point of index 0, so this point here, we'll say, and the end will be the second point that we're comparing against. So now we have this curve. We only want to add this curve to the geometry using a Shift A join geometry node if the distance meets this threshold. So for that if logic, we can Shift A and add a switch, plug that in through this geometry and true, and set this curved line to go through the true input. And we'll plug this less than into the switch. And now we can tweak this distance. And as I move that up or down, you can see that some of these connections appear or disappear depending on the distance we want. So let's say an even 1 shows us the behavior that we want in that some of these are connected and some aren't. So that's exactly what we want to see. Sweet, so this is good progress. Let's actually look at moving these points around so that we can see in real time if these connections are made as the distances between points changes. So to move the points around, let's go back to where we set up this point cloud. And we have a lot of connections connected to this point's output. We can shift, right click, and drag across all those lines just to tie them together to one of these reroutes. So I want to basically animate the position of these points. And usually when we're changing the position of something, we'll use the set position. So let's use noise to offset these positions. If we Shift A and add a noise texture and change this to 4D, we get this W input. And if we take this color and move it to the offset, you can see that the whole point cloud shifted. We'll fix that in just a minute. But as we change this W value, you can see how the points themselves change position. So we want to affect this using the frames of the animation. So that means we need a scene time input, and we'll take the frames and plug that into W. Now the problem will be if we press play, it's changing way too much. So we can Shift A and add a math node and multiply this by some arbitrary value to start, 0.01 maybe. Now we have the movement much slower. And you can see as the position changes to the point that it's too far, those connections are broken, or if they're close enough, the connections are made again. So that's precisely the behavior that we want to see at this point. Now I mentioned that when we plug this noise texture in, it shifted the whole point cloud up. Let's fix that really quick. The reason is the noise texture produces values between 0 and 1, which means it's centered around 0.5. So we want to recenter it around 0 so that we're not getting this whole point cloud shifted. And we can center it around 0 by doing a little bit of basic math. If we have 0 through 1, if we times this by 2, it will change the range from 0 through 2. But then if we subtract 1, it will change the range from -1, because 0 minus 1, through 1, which means it's centered at 0. So to do that math, let's add a vector math node. We'll scale it by 2, which is the same as multiplying by 2 on all 3 fields, the X, Y, and Z. Select the scale node, Shift D, and then we will subtract 1 from it, and that recenters our point cloud. So now what we need to do is make sure that we are comparing every point for every point, not just a single point to every point. That means we need a double loop, a double repeat zone. But we can take this whole loop here and press Control G or Command G on a Mac, and that'll nest all those operations within this single node group here. Let's bring these a little closer so they're easier to see on screen. And now we need to run this whole node group in another repeat zone. So that will take a bit of rewiring, but not too much. We'll add a repeat zone. And again, this point cloud result will go into the iterations. This geometry will flow through to the output. This geometry will go into the outer loop's input, and this geometry will connect like so. So we'll call this the outer loop. The outer loop is going to stay at one point while the inner loop compares all of the other points. Then the outer loop will increment to the next point, stay there while it compares all of the other points, etc. Which means, just like we did for the inner loop, we also need to create another index on this node. We'll call this outer index, set it to a integer. We'll start at index 0. That will pass through the loop, but right before the very end of the loop, we'll also increment that by 1. And this is kind of bulky, so we can press H to hide it, and then F2, and I'll just say outer index plus equals 1. That just means we're incrementing the value of that index by 1. So now we need to get this outer index into the inside loop so that we can use its value instead of this fixed value that we have here. So to do that, let's grab this socket, drag it to this group input, and plug that in. And now if we press tab, we'll back out of the group and we can see that we have this index here. Well, we want to pass the outer index into the inside group. The inside group won't modify that index. It will modify it outside in the outer repeat zone. Let's actually press F2 and call it inner loop. Let's change the name of this index so that we know which index it refers to, it being the outer index. So tab into the group, click this group input node, click the group in the sidebar, and we'll call this outer index. Wow, that worked out easier than I thought. So we have all the connections being made from every single point to every single point. That's pretty awesome. Sweet. Okay, so right now we're inside this node group. Maybe what we can do is rename this to inner loop. And now if we tab into the node group, we can see that we're inside the inner loop. That'll be handy in the future because we'll probably need to jump back and forth between the outer and inner loop. So here is this number that determines whether or not a connection is made depending on the distance. Let's make this adjustable so that we can tweak it in the geometrynodes modifier in the modifier stack. So if we drag from this input socket to this group input and then press tab to back out, now we have this property available on the outside, and we can drag from there and connect it to a group input. Press N and we'll rename that to minimum distance. So now we can adjust that just within the modifier stack, and you can see that it alters the connections in the 3D viewport. That's feeling a little fast. I'm going to slow that down just a little bit more. That's better. Actually, I see a problem. We're gonna have to fix something here. We've got a few lines, but we have a lot of splines. So each of these black lines is one spline within our geometry, but that does not seem right. Let's actually go and dial down this density. That's a good way to look at it. We've got 3 points. I only see one line here, but we have 5 splines. So that's not right. We need to figure out why those are stacking up. I think we need to adjust the logic here because when we go over these points, we compare 0 to 0, and then we compare 0 to 1, and then we compare 0 to 2. Then we compare 1 to 0, 1 to 1, 1 to 2. So we're actually double comparing these. So I think we need to say we'll only add this spline in if the inner index is greater than the outer index. And that way we won't be double comparing. Let's see, compare, and we'll compare integers so that this inner index is greater than the outer index. And now we need to AND this together with some Boolean math. And that seemed to fix it. Now we only have the one spline registered. We still have our initial 3 points. We have one spline. So if we adjust this minimum distance to the point that we get 2 splines, we do indeed have only 2 splines. Awesome. All right, so a small tweak to the logic, and we can go back if we want to the 5. That looks a lot more valid that we have 18 splines. So awesome, we're in good shape. So now let's turn this into actual geometry. Now, when the geometry comes out of this outer loop, it's got a mix of splines and points. On the points, we can add icospheres, and for the splines, we'll convert those into meshes. But how do we separate out points and splines? Well, there's a handy separate components, and we can use this to take one of these components, either mesh or curve or point cloud, and use the data inside. In this case, let's instantiate icospheres on the points. So we'll take the point cloud and we'll say instance on points. And let's grab Shift A, an icosphere, plug that in as the instance, and Shift A to bring in a join geometry, and we'll plug this in here. I'm actually going to Command right click, cut that connection, and let's change the radius of these icospheres to something like 0.02 maybe, 0.03. And we can change the subdivisions a little bit. I don't want too high, but then we can shade smooth just to smooth that out. Okay, so now we have the icospheres. Let's grab the splines, and using the same thing, we'll separate the components. We'll grab the curve and we'll say curve to mesh. And it won't do anything until we have a profile curve. So we can Shift A and bring in a curve circle and plug that into the profile curve. Let's change the resolution to 6 and the radius, shrink that way down to 0.005 maybe. And all right, this plexus is coming along really smoothly. Let's make these adjustable. Let's give this a group input, and we'll call it line radius. And just to differentiate between this radius, which we'll also set to a group input, and we'll call that orb radius. So now we can adjust those values in the modifier stack. All right, let's press Command Option Spacebar. We'll go into full screen mode. That'll let us kind of zoom in here better. Let's select these, press Ctrl J and F2, and we'll call it points. Grab this frame. These here, Ctrl J, F2, and call it point offset. We have this inner loop, which we called inner loop, the outer loop, and let's take these here, Ctrl J, F2, we'll call this orbs, and these down here, Ctrl J, F2, and we'll call lines, and Ctrl Alt Spacebar to get out of full screen. All right, that is looking super cool. We've got a clean node graph. We've got adjustable parameters for this plexus effect. So the next thing that we'll want to do is give it some color and some vibrance and give it that sci-fi glow effect. So let's dive in. But before we do that, if you're enjoying this tutorial, do me a favor and click the like button and subscribe. That helps the channel grow and it helps other Blender artists find this content and learn along with us. All right, let's get to it. So let's jump into the shading. Let's start backwards this time though. One of the things I commonly do when shading is I forget to set the material. So if we Shift A, set material, and Shift D, put that on this line, we'll specify materials for both the orbs and for the lines. So let's go make those right now before we forget. Let's go into shading. Let's create a new material. We'll call this orb. And I know that we'll need to set up some color on the points, and that'll be a stored attribute. So we can access that using an attribute node. It will be a color, which we'll call color. And the orbs themselves, if we go back to the geometry nodes, the orbs are instances. That's kind of key here. The color information will be stored on the instances themselves. So in the shading tab, we'll have to specify that this type is instancer. And we'll say the strength will be 10, just for now. We can duplicate this by clicking this copy button. We'll call it line, and we'll leave everything as is, except this color data will come from the geometry. And that's because in this lines group here, we take the splines and we promote the splines to an actual mesh. And the mesh is in that geometry. So for the orbs, we'll call it orb. For the line, we'll call it line. And in the 3D viewport, we'll go to material preview. Right now, we don't have any data coming through. So let's set up some color data. And we can set data on the points themselves right after we make this point cloud. So if we Shift A and store a named attribute, this named attribute will be a color. We'll call it color, and we'll set up a color ramp that has the color palette that we want. So for a color palette that you like, you can find any kind of color palette website and copy the hex codes from that website into the color ramp. And so I have a color palette that I like. So in the color ramp, I'll click plus and plus again so that we get these 4. And to select one of these stops, you just click it and then click the color. Go to this hex segment here and then paste in your hex code. And really quick, I'll just copy the rest of the colors over. All right, now when you have your color palette in, you can click this arrow here and distribute stops evenly to space the stops evenly throughout the color ramp. And I want these points to be noise driven. So if we add a noise texture, take that factor and plug it into the color ramp factor, we actually can start to see some of the color coming through. Let's go up into the shading and enable the scene world and the scene lights. Let's go to the render tab, change this to Eevee, click bloom. So we do see the color from those points. And last of all, let's go to shading, come down here to this drop down, set to world, click the background node and press M to mute that node. So we won't have any kind of lighting information in our world. We just get this glow. So that's looking pretty good. Let's turn up this density a little bit to see the distribution of colors. Right now, there's not a lot of variation. So let's add a map range node and just play with these numbers until you see the variation that you like. I like that. I can see all 4 of the colors. But now the next thing to do is to get the colors on the lines. So it was easy to get the colors on the points, on the orbs, because the points themselves have those colors. And then when you make an instance on those points, the instance inherits that data from the point. So the instance has that color, which the material for the orb reads and displays in the 3D viewport. The problem with those splines that have become meshes is that we've lost that data. When we created a spline in this inner loop, we created it based on the points themselves, but we didn't change the geometry. We didn't change those points into additional geometry. So we just created a spline that has no color information propagated from the points themselves. So what we need to do now is we need to read the colors off of those points and then set those colors on the control points of this curve. So let's make a little bit of room here because that will get a little bit hairy. And just like we did with this sample index where we read the position, we'll sample the index of the outer and the inner point, and we'll sample the color information instead. And then we'll write that color into the geometry line here so that it's stored for later retrieval. We can select a sample index, Shift D, and we'll bring this down here. We'll change from vector to a color because we want to read the color. And let's bring in an attribute, a named attribute node. We'll change that to color as well and drag the attribute into the value. So this color attribute that's coming from the points is what we want to read from that index. And the index that we want here will be the outer index. And so now we have that color information. Now what we need to do is store the named attribute. We'll make it a color attribute. We'll drag that in here. We'll set its color to color. And for the selection, we just want to compare. We only want to set that color for the first point because the start point here is coming from the outer index. So we'll say this is a float. We'll bring in an index input. And if the index is 0, that's the color we'll store. And we'll take the same setup here and we'll sample the color index or the color value from the inner index all the way up top. We'll duplicate this and say if the index of the control point is the second index, then we'll set the color to be this value. And what we're missing is we need to plug in this geometry here. Easy enough fix. We'll bring that in there. And I want to tie that same geometry in here. So let's shift right click to make a reroute, drag from that to the second one. And there you go. Now we've brought in the geometry to read the value, the color value off of that. That's looking pretty nice. These orbs are looking a little bit big. So let's go and change the modifier for the orb radius to just a little bit smaller. You can hold shift to finely adjust those orbs. And even the line radius, maybe 0.002, looks pretty good. Let's go and go up to the render, go to color management, and just double check our settings. Maybe change this to filmic. That definitely makes it a little more vibrant. You can tweak the exposure. So we'll leave that 1.5, but maybe dial this bloom back just a little bit, holding shift and sliding this until I like the effect. Okay. So one last tweak here is let's go out of this inner loop. Let's add a scale here. If I just duplicate, Shift D, duplicate that scale, that will spread all the points out. To see the difference, you can mute that node with the M key, and they're all pretty tightly clustered. So this scale will just shift them around a little more. So you can play with that until you like the effect that it has. And let's maybe up this density. The FPS is set to 24. Let's change that actually in the output here. Let's change that to at least 30 FPS. So now we changed the FPS, we'll probably want to adjust this. There we go. So yeah, definitely want to spread this out even further. And we have in the modifier stack the minimum distance, and with that you can play around with how close those points should be so that they're actually connected. I'm going to come down to the end frame and just pump that to 1000 just so that it can play and look at this full screen. That looks pretty freaking cool. I really like how that looks. So I want to hear from you though. What did you learn from this project? And what concepts may have confused you? Let us know in the comments so that we can help out. Also, if you enjoyed this tutorial, check out this other video popping up right now. I think you'll like it. Just click and continue to level up your geometry node skills.